So today we're going to be having a look at how do we describe associations between variables. And the main thing about it is we're going to use this thing called a scatter plot. And a scatter plot seems a bit similar like what we were doing before with plotting points, except you see we don't connect them up. We just do a bunch of dots on the page. That's called a scatter plot. And we can have a look at whether it looks like a line or not. You can see in this first one, all the points almost line up in a line. Not a perfect straight line, not like the linear lines we were doing before, but it's pretty close. So we would call that a linear correlation. Why? Because linear just means line-like. And you can see here that they kind of look like a line. But have a look at the next one. The next graph doesn't really have a line shape, right? It's kind of got this funny little hump shape. So we would call that a non-linear correlation because it is not a line. Now, the other things we can talk about is to do with positive and negative correlation. Positive correlation will look like this. It'll point up to the right, whereas negative correlation will point down to the right. Alrighty. Now, we've learnt linear, non-linear, positive, negative, and now we need to talk about correlation. Strong, moderate, weak, or no. So these words are to do with how much like a line does it look. Does it look pretty much like a line? It looks quite like a line. I mean, it looks like a line, but it's not great. Or is there no line to be found? So that's really the idea behind these different levels of correlation. So the question is, if you think that it is linear, meaning it looks like a line, do you think it's strong linear, moderate linear, or weak linear? How correlated are it? If the points are all really tightly together, then it's probably going to be strong. And if they're a little bit more spaced apart, it's going to be weak. Somewhere in between, call that moderate. Let's have a look at a few examples and see how we go. So, the scatterplot shows map of the scatterplot shown maps the height and weight of 9 people. Describe any correlation in terms of positive or negative, linear or non-linear, and strong, moderate, weak, or none. Alrighty, so let's have a look. Now, the first thing that I noticed is that it looks kind of linear. Not perfect, right? You can see it kind of has a squiggle to it. But overall, there is this kind of upwards trajectory. So, because it's got that upwards, that means it's going to be positive, not negative. Because it kind of looks like a line, it's going to be linear. But it's not that straight. You'll notice that it kind of, if I was going to draw a line, I'd have to draw kind of like a fatter line just to fit all of the points in it. And so that makes me think that it's probably going to be what we'd call moderate. It's not quite all the way out to here, but it's also not really, really tightly packed. So I'm going to call that a positive linear, I should use the word moderate. So it's a moderate, positive, linear correlation. Alrighty, so then B, determine what relationship, if any, exists between a person's height and weight. Well, when we say that something has a positive association or correlation, that means that as one increases, the other increases. So, as the height increases, so does the weight. Alrighty, so as the height increases, so does the weight. And so some of you might think, well, if that's what we say because it's linear, then what, not linear, positive, what would we say if it was not positive? Well, if it was negative, then we would say that as the height increased, the weight decreases. So it means that as one goes up, the other goes down. So positive means that they both go the same direction, whereas if we were dealing with a negative, then as one goes up, the other would go down. Alrighty, so there we go. Pause the video, have a go at 4.3, and then I'll be moving on, finishing off chapter 4. So this is going to be building off what we've done up till now, and we're going to have a go through graphing and then actually using these words we've just been practicing to describe the graph that we draw. So, the Lifesaver Association wants to show that the number of lifesavers patrolling a beach affect the number of people who are saved each year. Using the data in the table, create a scatter plot to determine any correlation between the number of lifesavers and the number of people saved that exists. Alright, so let's put number of lifesavers on the bottom and the number of people saved on the... Alrighty, so from here, we just need to have a look. The number of lifesavers, the smallest number in that row is 1 and the biggest number is 8. So on the x-axis, 1 to 8. And for the y-axis, smallest number 4, biggest number 22. So I want to go from 0 all the way up to 22. And on the y-axis, I've gone up in 5s. Alrighty, so let's plot some points. So I'll do the first few and then we'll go from there. So 4, 12, 4 on the x-axis, 12 up. So it's going to be about here. 6, 18, 6 on the x-axis, 18 up. 2 and 6. 1 and 4. 5 and 13. 8 and 22. 4 and 11. Now this is the first number in which you'll notice that there are 2 above the 4. And that's perfectly fine. That's normal. Alrighty, so I'm going to go finish up my graph by putting in the rest of the points. One of the checks I did before, after finishing the graph, is just making sure that the number of points matches the number of points. So there are 11 points and there are 1, 2, 3, 4, 11 points in the table as well. So now it wants us to describe any correlation in terms of positive or negative, linear or nonlinear, strong, moderate, weak or none. Alrighty, first thing, linear, for sure. Look at that. Positive, it's going up and to the right, and it is strong. Those are tightly packed together. So for part B, I'm going to say it is a strong, positive, linear association, or sorry, correlation. What does positive mean? Well, like I said before, it means as one variable increases, so does the other. So as the number of lifesavers increase, the number of people saved will also increase. Alrighty, so that is the effect. Obviously, it kind of makes sense. If you have more lifesavers on duty, then more people get saved. Alrighty, thanks for watching. More questions, answers at the back.